Calculus class.
Thank you, Mr. Richard.
Alright, good morning guys. There's a couple assignments I need you to make sure your name's on and turn in. That would be 11 and 13. I also gave you assignment 12 last time I saw you, but you didn't have to finish assignment 12, which is why I'm not asking you to turn in assignment 12, but you will need to have it out because that's what we're going to start with here in a second. So if I don't have your 11 and 13, get that out and find your number 12 in your binder, please. Nash. Okay, last call. Any other 11s and 13s before they're considered late? Okay. Then today we're going to mostly focus on assignment 12, which is about the definition of continuity. So we took these notes last time I saw you, so we'll spend a minute or two just talking about the parts we already talked about. And then there's a couple more note pieces we need to take before I can just move aside and let you practice some of that. So it's 12. Okay, so this guy is all about how to know and how to prove something is continuous or not. So while you might be able to just look at a graph, or maybe if you're lucky enough, you could look at a function and tell whether it's continuous or not, you can't just say, hey, this guy's not continuous because he has a hole in the graph, or this guy's not continuous because there's a break in the graph. Like, that's fine to describe it that way to your friend, but the only way to mathematically prove something's continuous is all three of these things. It has to approach the same y value on the left and the right, which we call limits in calculus. There has to be a point there, so the point has to exist. And then, just because there's a point here, and the limit's fine, if that point's way down here or way up here, that's not good enough. The point has to be the same value that it approaches. The point has to equal the limit. So those are the three things that we're going to use a lot of on this assignment, and this three-part definition does need to be memorized. I would say that the quiz isn't finalized yet. Mr. Myrick is also teaching a calculus section this year, so normally I would have that done and fixed, but now I need some input from him. let him have some say in it as well. But I know I would put this on the test. This is something they tend to ask on the AP exam as far as justification for an FRQ, so make sure that you are practicing that accordingly. So, the part that I tried to emphasize last time, but again, it's been a while, it's been almost a full calendar week. To prove something is continuous, like this on the right, you cannot say yes, it is continuous and have justified that until you show all three parts of the definition. You have to show the left and the right limit are equal. You have to show that the point exists, and you have to show that the limit and the point are the same value. If you skip one of those things, you haven't justified that it is continuous. But if something is not continuous, like 1A, you can quit as soon as you find one thing that's messed up. You don't have to do all three parts. As soon as you know that it's wrong and you've showed that it doesn't work, feel free to quit. But if it is continuous, all three things have to be on there. Okay, so that's the part we talked about last time. Any quick questions about that before we look at the other piece of the notes? You guys awake yet? Okay, identify the type of discontinuity and where they occur. So I could just tell you algebraically do this, algebraically do this, and then algebraically do this. And you could follow those steps each time and get the right answer. And that might be good enough to get you to get the answer right on the test, but you really need to understand what's happening here to understand why this is going to work. Okay, so 3x plus 1, I'm not going to graph all these, but we actually know what this looks like. It's just a mx plus b formula. But the point I want to make here is that by himself, he is continuous. This graph, this is like 1/2 x minus 1, so he's also continuous. So a slope of a half and a y-intercept of 1. By himself, he is continuous. So if the top piece is continuous and the bottom piece is continuous, does that mean the function is continuous? No, that's not what the definition says. So what you have to do is you have to start going through the definition. So as you work each of these, try to look at the notes on the top of this page less and less. But the first, and here's how, even though this is continuous and this is continuous, let me just draw these. Here, and I'm not going to try to make them accurate at all, but here's a red function that's continuous, here's a green function that's continuous, but as a whole, it's not continuous because of this right here, right? For this to be continuous, these have to be the same. So I could care less about this guy's y values. I could care less about this guy's y values. Okay, I care a little more than that, but there. I don't care about his y. Okay, I don't understand that. Okay, I don't care about their y values, but what I do care about is right here. These have to be connected. So when it stops being the top function, and or the top piece of the piecewise function, and it starts being the bottom piece of the piecewise function, I need these to have the same y value at this time. I need to make sure that, sure, this is continuous and this is continuous, but they've got to connect so that the whole thing is continuous. So what I really want is, I want to figure out, sorry, this says identify the type of discontinuity, so I don't need to use the definition here. I want to figure out when does this and this the same thing. So this represents his y values, this represents his y values, and I need to make sure they're the same. But again, I don't normally care that they have the same y value, but I need them to have the same y value when it stops being this function and starts being this function. So set these equal to each other, plug in 4 for x, and we get 13 equals 1, which is not true. So there we go. This would be not continuous. If it's going from 13 to 1 at x equals 4, what type of discontinuity is that? right, it's a jump. If your whole graph is jumping from y equals 13 to y equals 1 in an instant, your whole graph is jumping. So that's one thing it asks for. What type of discontinuity? So I don't remember if it was this class, partly just because it's been so many days since I've seen you guys, but I know at least 2 of my classes, there was people who asked about the last assignment. You had lots of vertical asymptotes, which gave you infinite discontinuities, and you had lots of holes, which give you removable discontinuity. And quite a few people asked, well, how do you get jump discontinuity? Jump is really probably going to happen from a piecewise function like this. So, okay, and so jump discontinuity, and it occurred at this x value, at x equals 4. So for a second there, I almost did the definition, but I didn't read the question very carefully. It says identify the type of discontinuity. So it's basically telling you these are not continuous somewhere. So not so much about figuring out yes or no, but figuring out where and what type it would be. Okay, same thing on the second one, except this is a 3-piece piecewise function. So again, I'm not going to try to graph these accurately at all, but I need you to understand why I'm about to do the algebra I'm about to do. So this guy is a polynomial. Polynomials are always continuous. This guy is just a linear line, mx plus b. That's always continuous. And y equals 5 is a linear line. He only exists at -1 though. So it's something like this. So depending on if this point fits in here, it's going to depend on what type of discontinuity we have. It could be that this actually fits here and this point is actually right here, in which case it's not continuous. But like the last question, I don't care about this guy's y values. I don't care about this guy's y values. Can that hear me? Like, does it hear I don't want them and then it... I don't want this guy's y values. I'm sorry, this is magic to me. I have no idea what's going on. So basically, I need to figure out what's happening at this value. This is continuous, and that's really just a point, but y equals 5 is a continuous function. But either they're all nice and neat and at the same value, continuous, or if they're not, it's going to want to tell us what type is not. So really what I want to do is take this top piece and set it equal to the right piece. And that's what I tried to visualize for you by scratching it out, but it kept erasing it. So I could care less if these guys have the same y value, except when it stops being the top function and starts being the middle function. So I'm going to see at x equals -1, are these things really equal? -1. So we get -2 equals -2. So what I just figured out is the limit from the left, I'm basically doing a left limit here, is equal to the limit from the right. They're the same value. So it's approaching the same y value on the left and the right. The limit as x approaches -1 from the left is the same as the limit as x approaches -1 from the right. Okay, so does that mean this is continuous? No, it's likely to be, but this is really only the first part of the definition that we have proven. The second part says there better be a point there. So when I plug in -1, I get 5. When x equals -1, y equals 5. So a point exists. There's the second part of the definition checked off. But now think about what these numbers represent. This guy approached -2 from the left. He approached -2 from the right, but the y value is up here at 5. Does that look continuous? No. So we have discontinuity at x equals -1. And what type of discontinuity would it be if it looks like this? Perfect. If it's just a hole, it's removable. So I know you can kind of say, well, it looks like it's jumping up. If it's only jumping up for one instant, 1 point, that's not a jump discontinuity. That's removable. That's a hole. It's if your whole thing. Oops. So again, when you step back and just kind of take an outsider's perspective here, I'm not doing any real extreme algebra, but you have to understand how these pieces fit together to understand why I wanted those two to be the same at x equals -1. Checked it and they were, or they weren't on the previous question. But that's just one part of the definition. The other part is they got to exist and the limit has to equal the point, which it did not. The limit was -2, the point was 5. Not the same thing. Kind of would look like this. Of course, you know, the red and the green are not accurate at all, but visually that's kind of what's happening. Okay, and then the last question type, this is the one that there's no such thing as too much practice on. And this type of stuff gets much easier as the year goes on, but right now it's sometimes kind of tough to figure out what in the world are they talking about. So on your AP exam, what they love to do, if they're not going to just say, question 1 is some question you practice 50 times, and question 2 is not necessarily something you practice 50 times. Question 3, you know, that's algebra 2, you practice and practice and practice and practice, and then 1 or 2 of those show up on the test, and then you practice and practice and practice, and 1 or 2 show up on the test. On your AP exam, they do a little bit of that, but a lot of it is something like this question 4, where they say, okay, if you understand the skill, we can put some kind of a twist to the question to really test that you can do it and you just haven't memorized the process. So here's a piecewise function and it says what value of k is just some constant, what would k have to be to make this continuous? And for some people, you know, you guys like to see the question, you like to recognize it, you like to know I'm going to do this, this, and this, and then I'm going to get to my answer. Sometimes you don't know. Sometimes you just kind of have to dive into it and see what's going on. So I know for this to be continuous, this and this need to be equal during this x value. So kind of like the last two questions. Let me just say this continuous function equal to this continuous function. Don't worry that it's k, just let k come along for the ride. And I need those to be the same when x equals -2. That way the limit from the left equals the limit from the right, which is one part of what's being required to be continuous. Plug that in, I get -2 equals -8 plus k. And all of a sudden, it's pretty obvious what they want me to do with k. To solve for it, add the 8 over, k would need to be 6. So it's not usually harder, but sometimes it's harder to know what to do to start off. So my advice is just try to force yourself to start it like any other question, and after a few steps it kind of reveals itself on what it wants you to do. And then just kind of from a test taking strategy, let's say we take our test or you take your AP exam, you got an extra 10 or 15 minutes on a section, you could just go up here, plug in 6 for k, and work it like the previous questions. This at -2 was -2. This at -2, if this is k, would be 4 times -2 plus 6 if I'm right. And then I can just confirm. Plugging in 6 makes the limit from the left equal to the limit from the right. So I don't know if I would take time to do that when I had other questions on the table, but there's no reason that you couldn't plug it in and try it. The other thing you could do from a test taking strategy, at the beginning of the year, we don't do all multiple choice, but we tend to lean towards multiple choice around Unit 3. So if you didn't know, I guess you could try A, put it in for K, do this work, see if it works. If it works, great, there's your answer. If it doesn't, try part B. If it works, there's your answer. If it doesn't, try part C. You could do process of elimination, I guess, but that is not very efficient. Okay, is there anything you would like to clear up from these last 3 examples? Okay, seems okay so far? Okay, then what I need you to start with this morning is I need you to just kind of dive into this in practice so you can see if it's clicking or not, or what's giving you a hang up, so I can hopefully help you before you leave. This first question has 2 parts. You really should work this as 1 part. And again, there's a 3-part definition you should be checking. It's fine to flip to your front page and look at those notes, but each question you do this, you should try to quiz yourself and look at your front page list. That's what's going to help you memorize that 3-part definition over time. Okay, so go ahead and start there. And this will be the assignment I take up on Wednesday. So I think you will be able to finish this guy up pretty easily in class because you've got 70 minutes. So that's a ton of time for this. So as you finish this, go ahead and start on today's handout number 14, but I will give you specific directions about assignment 14 before you leave. But I will be asking you to do some of it. So if you finish assignment 12 before most other people, just move yourself along to assignment 14, please. Okay. a minute to pass back the homeworks, and then I'll offer to work out a question or two on the board if you're finding something you need help with. Again, I know it's a little bit early on this assignment 12. But if you've got a question, you've got a question, so no reason to wait. Gonna have the same issue with something else later on. So, is there any of these that you've been trying on your own on assignment 12 you're having trouble with? Not getting the answers from the class website, or you just want to see it worked out to make sure you're on the right track? Anything I can help with yet? Okay. I will bug you for questions here again in just a little bit, but as always, you guys are welcome to ask at any time. Feel free to interrupt me. You can raise your hand and call me over. You can bring it up to me. You can yell at me. No difference to me, but There is one calculator thing I would like to show you, even though you really don't have to know this. I just know that some of you are more calculator people than others, so this is usually something the students are not aware of. So this assignment 12, I actually graphed the piecewise function in my calculator for number 8. So this is what number 8 looks like. And I'm going to show you how I got it to do this. So notice it drew 1 minus x squared, but it didn't draw the whole thing. It only drew the part where x is less than 1, which is what this piecewise function asks for. And one limitation of this is it doesn't do points very well. So the second part of the piecewise function in question 8 is just the point. When x is 1, y is negative 2. So because that's only at an instant, calculator does a poor job of plotting points. So I have it in there, but it just doesn't show that. So on question 8, looks like there was a hole there. So that means you said there was removable discontinuity at x equals 1. That's what you have. And then at x equals e, notice here is natural log of x graph starting to be graphed, but it's only graphed from 1 to e. And then here's 4x being graphed when x is greater than e. So the second half of that question, this gives you a visual, and you can see at x equals e, there's a jump in continuity, right? So I'm not saying that you can, usually when we give you guys tests, we mimic the same way the AP exam would be. AP exam wouldn't give you a calculator in question, we wouldn't give you a calculator in question most of the time. So you can't count on this as a way to do your work. You need to practice the algebraic way like you guys have been doing. But this is a pretty nice check. Again, I know there's a point here, removable, this is jumping, this is jump. And then that helps you quickly confirm your algebra. So if you want to ever be able to do that, there's 2 ways to do it. And it's a big notation thing. So again, I just want this to be on your radar in case you ever want to try it, you can try it. This is not something I can help you with on the test, so if you want to be able to maybe do this on the test, you have to practice it some. But basically, I graphed the 4 pieces of the piecewise function, and then this notation, divided by parentheses, if you put the inequality here, it knows to only graph that part of that graph. Only graph here, graph this, but only when x is greater than e, graph natural log of x, but only when x is greater than 1 and less than or equal to e. So you have to know this divided by parentheses notation. You have to know to get those inequality symbols, like less than, equal to, less than or equal to, you hit second math. They're right here. To the right of that, there's the and. The and's needed if there's 2 parts, like this third part here. But if you know that notation and you have a calculator, sometimes you can give yourself a quick, accurate visual of what you're trying to work, and that might help you correct your mistakes. The second way you could do it, and I'm not going to type all this out again, but the second way you can do it is if you go to math and you go, I think, all the way to the bottom. Yours probably doesn't have this. So, in the newest calculator update that came out like last spring or something, they added a place for piecewise functions. So, near the bottom of math, hit enter. It wants to know how many pieces does it have. I want 4 pieces. And then what it does is it gives you a piecewise function with these little skeletons. So you can type it in and make it look like, well, this doesn't look super great, but you can type it in and make it look like it actually does on your paper. Now, since that's only if your calculator has been updated, if you have your personal calculator, the only way you could update it and get that is if you find the cord that came with your calculator when you bought it, connect it to your computer. There's a program that TI uses called TI Connect. You can download the newest operating system. You can send it to your calculator. But if you're willing to do all that, that piecewise will show up and it makes it look a little bit nicer than when I did it. So anyway, you don't have to know any of that, but I just like you to know that it's available. It's a thing your calculators can do if you know how to operate it. So consider practicing that from time to time. Otherwise, you won't remember how to do it when you want to do it. Okay. So I've been bugging you on that, but is there something else that has come up on assignment 12 at this point? Okay. I saw a few of you had already moved on to assignment 14, which is great. On assignment 14, I'm not going to take questions from that just yet. So if there's something you're stuck on or you don't remember how to do, just skip that question or two and go on to the next session. You will not need to have assignment 14 done when I see you on Wednesday. But I will ask that you have some of it done, so you might as well move on to it when you get there. Just checking in again. Anything from assignment 12 I can help with? Okay. 4 is not 0. So here's how much. This is 1 pi over 4. So you add that again, 2 pi over 4, or pi over 2. Here's 3 pi over 4. So right here, sine and cosine are the same length, but cosine's negative, sine's positive. So that should be negative 1 also. I still have a few calculators you guys can check out for the year. There's not many left, and the AP Stat students are going to take them soon. So if you changed your mind about checking out a calculator for the year, you need to tell me as soon as possible, because there won't be one if you keep waiting. Yeah. Give me just a second, I'll bring it to you. It'll take me a minute to get it checked out. Might have to work. That is yours. You don't have to turn it back in till the end of the year. It's just like a textbook. If it's damaged or lost, it's like $150. So take care of it, please. Yeah, give me just a second. I'll bring it to you once I get it checked in.
motion.
Yeah. So right up here, as long as it's not the first or last 10 minutes, put your name on the whiteboard so I know who has the pass, and then when you put the pass back, just take your name off the board. If anybody's still on assignment 12, you should be pretty near the end. Before I stop begging for questions for today, is there anything else on assignment 12 that would benefit you for me to go over? Any of those ended up on your test that you'd be more worried about than the rest? As Josiah gets back from the bathroom, I will give some directions on this assignment 14, so you know what I'm expecting from that. It doesn't exist, but that doesn't mean
zero over zero.
Right. So, it gives you 0 over 0. What'd you say? 1. Well, 0 over 0. What does that look like on a graph?
Is that undefined? Or
It is, but what is why? Like on a graph visually, what's on
What does it look like?
That's only if it's something over 0. Does it look like that? So when you have some number besides 0 divided by 0, you get a vertical asymptote, which means your discontinuity is infinite. But if you have a number that makes the numerator and denominator 0, that's what creates a hole. So that's how you know it's removed.
sign this for me, and you also have to put my math GPA in there. It's for me off of data.
Okay. Give me 10 seconds.
Okay. Do you want me to wait here, or should I go back?
Yeah, you can just wait here. It's fine. How do you say your middle name?
Anaquilla. It's Latin.
Yeah. Chelsea, do you have revalidation forms?
I do not.
Oh, okay.
That would be Mr. Driscoll.
Yeah. I didn't know if you did or it was just,
Do you know what room it is?
it's like 21 something.
It's one. It's.
I know where it
it's
is.
2103. Yeah, I just wanted to make sure because people were getting confused this morning.
I was in there last year.
No, pre-cal?
No.
You know your unit circle yet?
Yes, sir. Learned it in algebra 2.
You want me to quiz you?
Thank you.
Oh.
Oh, signature.
Signature.
Yes, of course.
Decides back. So let me speak on this assignment 14. So I told you to just go ahead and start it when you got to it. But we've got our first, what I call quiz, coming up. Ours is at the end of the week, so this will be when we round out our limits, continuity stuff. The reason I call it a quiz instead of a test, it's really the end of the unit assessment. But most years, and I assume this year, but again, Mr. Myrick has a say in it too, so I can't say for certain. Usually we only count this as a 20-point assessment. So early in the year, I mean, obviously that impacts your grade a lot. It'll be your only major grade temporarily. But most, if not all, the rest of the tests this semester are either like 50 points or 100 points. So in the grand scheme of things, limits don't matter as much, unfortunately. I'm not telling you not to put good effort into it, obviously. But whether you're great at limits or terrible at limits, it does not dictate the rest of the semester. Most of the first semester is about derivatives and such. So that's why I call it a quiz, because it probably will only be like 20 points, whereas everything else will probably be 50 points. So in the long run, this will be worth less, but that's where we're at. So this review, so again, your quiz is not next class, it's the class after on Friday. This is an 8-week. But I need you to do at least half of this assignment 14. So between now and Wednesday, I can tell some of you are already gonna have that much done in class. But I'm asking that you do at least half. It doesn't even have to be the first half. It could be any half. So if you look at the first set of questions and you say, I struggle with those, I know those are a weakness of mine, feel free to skip them. So don't count that as part of your half that's done. This way, you're putting eyes on a lot of different things. Hopefully you're identifying, these are not hard for me, I'll do some of those. These are hard for me, I'll save those. And then when I see you on Wednesday, at the beginning of class, you probably have some ideas of which topics you want to be reviewed on, and that helps us hit the ground running, so that if you do need lots of help and you do have lots of questions, there's more time to squeeze that in on Wednesday. So, again, I won't be taking up the time at 14 on Wednesday, but if you don't do at least half of it, if you come into class on Wednesday with none of it done, you don't know what your strengths, weaknesses are, what you had learned but forgotten, and you start working on that, you may not finish it and get the help that you need, and then you're just gonna be pushing all that onto yourself, trying to figure it out outside of class. If you do at least half of it, if not more, then when I see you on Wednesday, you've identified some of your weaknesses, and then we have plenty of time for me to help you. Now, I will also say, at least half is a good benchmark, but if you didn't learn limits last year, but this is one of the hardest things you've ever done, you should probably try to do the whole review before Wednesday, so that when I see you on Wednesday, I can help you with the things you can't figure out yourself, and it gives you some time to make sure you can wrap your head around that stuff before you leave. In advisory today, you'll sign up for movement. So most of the time, like 99% of the time, I'm available Tuesday, Wednesdays, Thursdays, and Fridays. Don't wait till Thursday to come see me if you know that you're falling behind now. There might be 5 other people who show up, and I might only be able to help you 5 or 10 minutes, so don't do that. That being said, I won't have advisory on Wednesday because I have an AT department meeting. So Tuesday or Thursday would both be 2 good days. You could come see me if you know you need extra help. So that's all I needed to say about that. So this is down here, this is incorrect. I'll need to update the homework down there. 14 does not have to be finished and ready to turn in. You should have at least half of 14 done to make sure that Wednesday we've got time to get you the help you need, get you time to finish it, and then make sure that you at the very least know what you need to study and how much time it's going to take and all that kind of stuff. So, any questions about any of that? So I will ask for assignment 12 on Wednesday. So again, I'm pretty sure you guys are finishing that up, but just like all of our assignments, make sure you have it finished. Make sure you check your answers. Don't accidentally skip a question. Don't not check your work and not know that you're doing it correct or what you're not doing correct. And then of course that should be pretty easy class points if you do that. So. Okay, everything okay with that? No questions? All right, again, you got about 10 minutes, so try to get a little bit more done. Before you find a stopping place. Alright guys, we're down to about 4 minutes here. So finished or not, time to find a stopping place. Again, all of 12 needs to be finished, checked, and ready to turn in. 14, aim for at least half. More if you're concerned about Friday's quiz, or half if you feel like you're close to being ready. While you wrap up, I think the most recent puzzle I gave you was the mice puzzle. Did y'all see the mice puzzle yet? Or the rats? The last one was what? The sock? Oh, what did y'all get for the answer on the sock? That's correct, 11/23, which is just under 50%. Very good. All right, there's the one I shared with you today, if you're interested.